Yeah. So what else is what I wanted to show you is here. Here's a similar execution plan, and that is also the reason why this is a different plan than the real-time signal monitoring report. This is a rack cross-instance parallel execution analysis, and I just wanted to show you that in principle for a cross-instance parallel execution on execution plan line level, it is pretty much the same information that you get. Again, if real-time signal monitoring information is available, the corresponding columns will be populated. I think the only difference that is worth to point out is here this information that for the processes they have this prefix from which instance they come. So you can see here that we have here this 2 minus P000 means this is parallel slave P000 from instance number 2, and this is process P000 from instance number 1. So in order to be able to distinguish between the different processes on different instances, you get this prefix here, which is simply the instance where this process runs from. So that's the meaning of this, which you only would see for this cross-instance parallel execution. For a single instance, you don't have this prefix because there's no point in the prefix. Yeah, so that is the only significant difference for a cross-instance parallel execution, that you get this instance prefix. Another point that another thing that I haven't explained yet is this leading number here with this, which is as prefix to the total line here. It's just in information how many different processes were actually found to be active in active session history for this execution plan line. So this means in active session history for this execution plan line, exactly one process was found to be active, which you can see confirmed here that all other processes have 0 samples. Here we have 3 processes with samples greater than 0, so these 3 here are meant, and so on. So here again we have only one process with a sample, and that's the reason why we have this 1 here before. Just wondering here again about this double accounting. Maybe this is the P004 from this other cursor, this other child cursor. Anyway, another thing that I haven't mentioned is that these processes here are ordered by the number of samples. So the process with the most samples in active session history comes first. So that's the reason why P03 is here first, because it has 13 samples. Then P05 10 samples, P04 4 samples, and so on. So that is the idea here, so that the processes are actually ordered by number of active session history samples descending. So obviously the processes with the most samples come first in this output. So that's the idea, and that is the order that determines why you see here a different order in these processes. That is because they are always ordered by the number of samples. Okay. What else do we have? In case there is no execution plan available, which might happen because either the execution plan has been flushed from the library cache, or maybe it hasn't even been recorded in the AWR. That's the reason why there is also this mixed option here. So you have these three different modes for the active session history. Mode of ExplainASH current means take all the information from $v active session history and take the plan from the library cache. Hist mode would mean take the active session history information from DBA hist active session history and take the plan from the DBA hist SQL plan view. And mixed means take the samples from $v active session history but try to get the plan from the AWR, so to get the plan from the DBA hist SQL plan view. So that's the reason why there is this mixed mode, because you might be in the situation where the plan is no longer available from the library cache. Then you can switch to this mixed mode, and if you are lucky, then you get the plan from the AWR, and then you still get this plan shape here. Although as you know from DBA hist SQL plan, some information is missing. You don't have this filter and access predicates, but at least it's better than no plan at all. If ExplainASH does not find the plan in the selected source, so either in library cache or AWR, then it would fall back to this mode here. So at least it then tries to extract as much information from active session history and from real-time signal monitoring as possible, so that you get on execution plan line level, you get then what is available from active session history. Unfortunately, if the real-time signal monitoring information is available, in principle the plan would be available from real-time signal monitoring, because that's the source where this report here is based on. This doesn't use the library cache information of the plan, but uses the information from $v SQL plan monitor. That's also the reason why you don't see here the predicates, for example, which I find actually not that nice that they do not include the predicates. You only get the predicates if you switch here to this plan view, which is then again based on the library cache information. If the library cache information is not available, then this tab here would be missing from the real-time signal monitoring report. But this here could still be available because it's based on this $v SQL plan monitor. But in ExplainASH, since I base this information on DBMS Xplan, on the DBMS Xplan package, I can't use the $v SQL plan monitor as source for DBMS Xplan. I tried it to use it, but there are simply some crucial columns are missing. You can use via this DBMS Xplan display, you can specify the plan table name, so you could in principle use $v SQL plan monitor as input, as source for DBMS Xplan.display, but there are simply columns missing, so DBMS Xplan display doesn't work. I've already thought about somehow finding some way to use this as input source, but so far I haven't managed to get it working. So in such a case, if the plan is neither available from library cache nor from AWR, then even if it was available from real-time signal monitoring, ExplainASH at present can't use that information to show an execution plan, and would then fall back to this output here. So you get here the plan lines that were sampled in active session history, the plan operation. This is what you get from this is what is recorded in the active session history. It's better than nothing, but of course not as useful as a full execution plan shape. You also get the plan hash value, and you get this additional columns here that well, basically would be injected into the official DBMS Xplan output, and the meaning is the same. You see here this cell offload percentage column. In this case, I also show columns that do not have any information populated. These will not be shown in the DBMS Xplan output, but the meaning is more or less exactly, not more or less, the meaning is exactly the same. So what I've just explained on execution plan line level based on the DBMS X-Plan output, extended DBMS X-Plan output, the same would apply to these columns here. One thing I see I haven't mentioned is this the active column here. If you had an execution, let's see if I have an example here. I think all of these were already completed when I generated the report. If an execution was still ongoing, then an additional column would show up here on the left-hand side. This active column here would show up, and it would simply contain such an marker here that it highlights the corresponding execution plan lines that were active, I think, during the most recent 10 seconds. So it's just basically what you also get from real-time signal monitoring. If you do a real-time signal monitoring, it will also highlight here which execution plan lines are currently active. And again, this activity indicator in ExplainASH is based on active session history, whereas the activity indicator here in real-time signal monitoring is based on the monitoring information. So again, they could be different. They could highlight different execution plan lines, but the basic meaning is the same. It tries to give you an idea which execution plan line most recently was active. ExplainASH based on active session history, and real-time signal monitoring based on the monitoring information. Again, you can argue which of the two sources are maybe more helpful, probably depending on the situation, one or the other. But I decided to use active session history for this activity indicator on execution plan line level. So that's another information that you get only if the execution is ongoing. And finally, I think what I wanted to show you here is this information here. If you have an execution that involves bind variables, then similar to what you get from the real-time signal monitoring information, you have here this option to show the actual bind values, which is a very helpful information, because it's not that easy to obtain that information if you do not have real-time signal monitoring. If you do not have the tuning pack license, then you can only do cursor dumps or things like that to obtain this actual bind value information. Many people believe that what they find in $SQL bind capture would actually be the actual bind values used, but $SQL bind capture is only based on sampling. So what you find there is not necessarily what actually got used for this particular execution here. So you have to be very careful and do not come to wrong conclusions based on $SQL bind capture. Real-time signal monitoring includes the actual bind values used for this particular execution. So this information, this bind value information, if it is available, is also here in a separate section available in the real-time in the ExplainASH report. So this is the same source. This is the actual bind value taken from real-time signal monitoring. And the nice thing is that in the ExplainASH output, you can then very easily compare the actual bind value to the peaked bind value that was used to generate the plan. So since the ExplainASH display cursor output by default, or the display function call by default, includes the peaked binds option, you would see here the peaked bind. This was the value that the optimizer used to generate this execution plan here, and this is the actual value. This one here is the actual value that was used for the bind with the name or position, with the name X at position 1. And here you see for this bind X at position 1, 100,000 was the value used by the optimizer. So this gives you, usually if you have a bind variable picking problem, these two are the crucial parts that you need to understand what might have went wrong. And that's the reason why I have also included in the ExplainASH output, if real-time signal monitoring information is requested and available, then this actual bind value section here will be shown, and this peaked bind is something that you, I think, unfortunately don't get from the real-time SQL monitoring, again because the information here is based on VDOLA SQL plan monitor. I don't know whether this representation here, I don't think that it contains the peaked bind value, because this is what you get from VDOLA SQL plan. So in principle, this information here could include the peaked bind. Well, if there was something based on the other XML information, no, it's not. Even in 12c, it doesn't seem to be there. Yeah, but in ExplainASH, as I pointed out, you get this information. Yeah, so I personally like this very much. This way ExplainASH combines all this information, so you have this full DMMS Xplan output with all the information available, in particular also this information, this query block outline information, and in particular the predicate section. You get all this in a single view, and you get this additional columns here, like this part from real-time signal monitoring and active session history, to give you an idea about the activity distribution on execution plan line level. So I personally like this very much, that I have all this information at a single place, although it becomes usually a very wide output. So it's not that easy maybe to read, but I personally prefer to this here, where I might have to switch between this tab and this tab, and to get an idea about these various things that might be crucial in understanding the actual execution plan on plan line level. Well, I think that pretty much is it what I wanted to point out. Maybe just something that I might pick up on another part of this series here is that you can configure this here. So for example, here it says the top 5 activity. If you want to see only the top 3 or the top 10, you could configure this in the script configuration section, how many should be shown here in this column. Likewise, I think it can be configured how many of these processes are shown. I think by default are 5 or so of them. The top 5 are shown, and this ... then indicates that there are more processes that are not shown here. Also something that can be configured. So just to have this mentioned, that you can customize this output. And as I already pointed out, this or execution order information here is not shown for parallel plans. Yeah, I think that's it, and see you at the next part of this tutorial.